theorem that will help us to calculate the number of subbooleans. Okay, the number of subbooleans from any Boolean algebra. We know that if there is a Boolean algebra, we can figure out some specific subboolean or subboolean algebra of that particular Boolean algebra. Now, to get the number of subbooleans and what is the representation of the subbooleans, we always use Stone's representation theorem. So, first of all, what is Stone's representation theorem? It tells us that every Boolean algebra will always be isomorphic to a power set algebra. Like this is a Boolean algebra B is always isomorphic with the power set algebra, or means the power set of A. Okay. So now we know very well that power set of A. Okay, power set of A is having the number of elements is actually represented by 2 power n. If I have n number of elements in the set A, the power set of A is having 2 power n number of elements, right? Since B or the Boolean algebra is always isomorphic to power set algebra, so it is always true that the number of element of that Boolean algebra can be represented as 2 power n only. The number of elements of any Boolean algebra is always represented by 2 power n only. Okay. Now, this means what? It means the number of elements in the Boolean algebra is either can be 2, 4, 6, 8, 2, 4, 8, 16, or 32, or 64, whatever. Okay. Now, my question is that how to identify in exam this is a Boolean algebra or not. Okay. If they ask you some question like whether S30D is a Boolean algebra or not in 8 marks, then we will going to check each and every step-by-step method like commutative property, then we'll go for associative, then we'll go for absorption. After that, we'll check the distributive law as well and complement lattices as not, that all things. But if someone asks you in 1 mark only, that's whether S30D is a Boolean algebra or not, how to check? So what's the step? The basic step is that we will calculate calculate the number of elements in S30. So how to calculate the number of elements of S30 is a very simple rule is there. We will represent 30 as a prime factorization. 30 can be represented as 2 times 3 times 5. Okay, this is a prime factorization of 30 because 2, 3 and 5 are 3 distinct primes. Now it can be represented 2 power 1, 3 power 1, 5 power 1. So number of elements of S30 is actually 1 plus 1, 1 plus 1, 1 plus 1. So you can multiply, you can get 8, and 8 is a form of 2 power n. Since 8 is a form of 2 power n, that means number of elements in S30 is having the form of 2 power n, that is, this should be a Boolean algebra. Definitely this is going to be a Boolean algebra. In similar manner, if someone asks you about S64D, now 64 is a number which can be represented 2 power 5, so 2 power 6, only 2 power 6, okay, because no other prime number is going to be divisible by 64. 64 is is divisible by no other prime number. That means what? number of element in S64 is 6 plus 1, that is 7. 7 cannot be represented as 2 power 1 n. So 64D, S64D is not a Boolean algebra. This is the technique we can check, we can apply for any Sn. Okay, so for any Sn it's going to be easier to check. But what about other set? In other set, we will count the element. Okay, every set there is a process to check or to count the each and every elements. Okay, total elements of the set. So we'll count the total elements of the set and check whether it's equals to 2 power n or not. If it's equals to 2 power n, like 2, 4, 8, 16, 32, then definitely that is going to be a Boolean algebra without loss of generality. Now, this type of question can appear in your exam as 1 mark. Okay, just 1 mark you can check by this thing. Yes, this is the easiest way. Okay, it is the easiest way, Matthews. But the fact is that we can do only in case of 1 mark. Okay, whenever someone asks you for 8 marks question, you have to go through for all those steps like commutative property, associative absorption, then complemented lattice, distributive lattice, each and everything you have to show. Now, so just what Sn represents any Boolean algebra. Okay, I want to find the number of sub-Boolean of Sn. For the time being, let us assume that the total number of elements in Sn, let us assume that total number of elements in Sn are 8. So total number of elements in Sn are 8. Now the sub-Booleans means a subset of Sn. So what are the possibility of the number of elements of the subset? First, it may be possible that 2 elements present in the sub-Boolean. It may be possible that 4 elements present in the sub-Boolean. It may be possible that 8 elements present in the sub-Booleans. Okay, sub-Booleans is a subset of original Boolean algebra. Now, why 2, 4 and 8? Because again sub-Boolean is having that representation 2 power n. It is not possible that sub-Boolean is having 3 elements, 5 elements. Okay, because a sub-Boolean is also having that 2 power n formula. It should satisfy this 2 power n formula, that number of elements in the sub-Boolean is also 2 power n, as well as the number of elements of any Boolean algebra is always 2 power n. Now we want to classify these things into three cases, right? So the first case, whenever we have 2 elements in the sub-Booleans. The first case, case number 1. The second case, whenever we have 4 elements in the sub-Booleans, and the third case we have 8 elements of Boolean. Now, if suppose I have the Boolean algebra with 16 elements, then we can classify them into 4 cases. One is for 2 elements, one is for 4, another one is 8, another one is 16. If I increase the number of elements of Boolean algebra, according to that, the cases will increase. Now we will discuss the case, and according to the case, we will count the number of sub-Booleans. So your target to count the number of sub-Booleans. Also, we have to express a specific structure for sub-Booleans. Right. So let's go for the case number 1. So case number 1 is if the sub-Boolean is having only 2 elements. As I told you, it can have 2, 4 or 8 elements. 2 elements is the first case. The 2 elements should be, and it should be obviously these 2 elements, like 0 element and I elements. No other elements possible. One is 0 element, another one is the I elements. That should be the 2 elements of. Now, why is this so? Because 0 elements and I elements must be there. Otherwise, we cannot find the complement of each and every element. So we know that 0 elements is having its complement, and this is I elements, and I elements is having complement of 0 elements. So they are complement of each other. That's why it's satisfying simultaneously. Case number 2 is having 4 elements of that sub-Booleans. Case 2 is having 4 elements of the sub-booleans. Let's say it can be represented as 0 a n by a I. This, what is this a? A means this atoms, number of atoms of this Boolean algebra. If the Boolean algebra is having 3 atoms, okay, so whenever generally in any case of Boolean algebra, if I have a total 8 elements, okay, so obviously it will have 3 atoms, okay, because by the structure of the hash diagram, okay, if it is a Boolean algebra and it is having 8 elements, so it must have the 3 atoms. If it is a Boolean algebra, it's having 4 elements, it must have 2 atoms. If it is a Boolean algebra, it's having 16 elements, it must have 4 atoms. So whenever we have 4 elements in the sub-booleans, the first structure, the first part of the structure is going to be 0 a n by a I. So a are going to be your atoms. So if there are 3 atoms, so we will put the a1, a2, a3, and depending on that, we'll go for the complement. So a is a complement of I, 0 is a complement of I, a is a complement of n by a. Why I put n by a? Because I have used here d as a divide, as a relation, divides as a relation. That's why n by a. If the relation has been changed, suppose I change the relation like subset, then n becomes it's a minus that set a or whatever x, a minus that atoms. Okay. Depending on the subset, we will choose the complement element of that atoms. Now another possibility of that case 2 or the 4 elements is 0 GCD LCM I. 0 GCD LCM I. If you check in some case, like if I take a GCD of 2 elements, two different atoms, okay, always you will get the old set after calculating the second part. That means what? If I use 3 atoms already, so 0 a1 n by a1 I, the first set, second 0 a2 n by a2 I, second set, third is 0 a3 n by a3 I, third set. Now whenever I calculate GCD of AB, so GCD of AB, if I calculate, it is possible that it will be same as either n by a2 a3 or a3 whatever. That means I will get only this type of set after calculating GCD of AB and LCM of AB in many times. Okay, so whenever I will get a repeated set, we will not consider this one. We will ignore any repeated sets. We will only calculate the non-repeated sets. Okay, so after calculation, we will write the total number of possible sub-booleans from case 2. If it is 3, we will write 3. In the first one, obviously there is only one possibility, that is s equals to 0 I. Then we will go for case 3. Case 3 is having 8 elements. Now my question is that if I have 8 elements in the sub-booleans, and we know that the Boolean algebra is also having 8 elements. 8 elements of sub-booleans, and Boolean algebra is also having 8 elements. So what we can do here, if I want to find out the sub-booleans of 8 elements, simply it will be nothing but that Boolean algebra in itself. Okay, it will be the Boolean algebra itself only, right? So just a minute. So it will be S equals to Sn only. So whatever your Sn, if you calculate the given Sn is there, that is only your sub-booleans in case 3. That means in case 3 we will have only 1 possibilities. And the structure of the case 2 is A0A, N by A, A by B, A, B, C you can write 3 atoms A, B, C, N by A, N by B, N by C, or else you can take LCM of ABA, N by LCM of AB, LCM of BC, N by LCM of BC. Whatever you can take, you will get only one set, that is Sn. No matter how you are taking how you are constructing the possibilities. Okay, you will get only Sn. So in case 3, only one representation is also will be there, that is Sn. So depending on that, we will count the total number of representation and we'll write the total 5 or 6 or 7 sub-booleans are possible. Okay. Matthews asked me that, so what about 1? Yes, Matthews, 1 is 2 power 0, but we will not consider that 1. Okay. Because if I consider only one element is not present. Suppose one element means either I have to give some occupation of 0 element or 1 element, I elements, because at least 0 elements and I elements should be there inside the set. So at least 2 elements will be there. That's why we will start from 2 power 1. Okay, 2 power 0 is not possible. Okay, good. So let's proceed for some example. So this example is actually S105 GCT LCM complement 0 elements and I elements of Boolean algebra. If possible, find total sub-booleans of the sets. So what is S105? S105 is having 8 elements like this: 1, 3, 5, 7, 15, 21, 35, 105. And the atoms are 3, 5, 7 only 3 atoms are there. Now we want to find out the sub-booleans of this. The first case number 1, is having 2 elements only in the atoms, 0 elements and I elements. So 0 elements is 1, we know that, and I elements is 135, we know that. So we can put 1 and 135. Is 1 and 135 is going to be the first case and is having only 1 sub-booleans. We already get 1 sub-booleans. Count number of sub-booleans. Okay. Case number 2, if the sub-booleans is having 4 elements. Okay, so sub-booleans having 4 elements means the first case is 1, the first atom. So first atom is 3. N by 3, here n equals to 105. Okay, n will from Sn. Okay, n is a part of Sn. So n is 105. So 1, 3, 105 by 3 by 1 and 105. That means 1, 3, 35, 105. 3 and 35 are complement of each other. 1 and 105 are complement of each other. Next, another possibility. 1, 5. 5 is the next atom. 1, 5, 105 by 5 and 105. That means 1, 5, 21, 105. So 5 and 21 are going to be complement of each other. Next one, 1, 7, 15, 105. Now you may ask me now that if I consider the GCD or LCM of any 2 elements, so what happened? So let's take this LCM of 2 elements. So 1, let's say LCM of 2 atoms, like 3 and 5. So what is LCM of 2 atoms? 3 and 5, it's going to be 15. So, and this element should be 135 by 15, and these elements will be 105. Now what is the set? 1, 15, 7, 7, this should be 105, sorry, and 105. So this set and this set are same. That means it's a repeated set. So we will not consider, we will ignore this one. So only take that set which is not repeated or non-repeated one. So we will consider the non-repeated set only, and there is only 3 possibilities under 4 elements. So total 3 sub-booleans present or possible under case 2. Now the last case, case number 3. I think it's not visible. I will write it up. So case number 3 is having only one possibility, that is if I have 8 elements, that is only one possibility. S becomes S105. So S105 means 1, 3, 5, 7, 15, 21, 35, 105. So 1 complement is 105, 3 complement is 35, 5 complement is 21, 7 complement is 15. Each and every element is having its own complement. This is a specific subboolean. So how many subbooleans are present here? 5. 1 plus 3 plus 5. So total number of subbooleans is equals to 1 plus 3 plus 1, that is 5. 1 plus 3 plus 1, that is 5. So this is the method. This is the use of Stone's representation theorem. And using Stone's representation theorem, we can easily calculate number of subbooleans of any given Boolean algebra. Okay. If it is clear to all of you, please write down C on chat box so that I can move forward. Please write down quick C on chat box. Matthew's case 3 means it's having 8 elements. It's having 8 elements in the set. Okay. So whenever we have 8 elements in the set, and we know that the main Boolean algebra is also having set 8 elements. Is it possible that S becomes some other set compared to S105? Is it possible that I can some that set which is also subset of 5? Okay, let's consider A, B, D. Okay. So I'm saying that elements A1, A2 up to A8. Okay, I'm saying this set of S105 is a set of S105. So S105 is having 8 elements only. Having an element, also subset is having 8 elements. Is A1, A2 up to A8. Is it possible A1, A2, A which is not equals to AS105? Is it possible to find some other set which is not equals to AS105 under this condition? Please write down on chat box. Not possible. So that's why AS becomes only AS105. So in third case, it is only one possibility, that is AS105. Hope it is clear to all of you. David, is it clear? Zacharias, Eba, Selamavit, Nahum, Gloria, is it clear? Right. Good. All right. Proceed on other example. So this is for you. Solve it and write down your answer on chat box. Total number of subbooleans. Yeah, this is S30 is having 8 elements. So first of all, write down on chat box what is S30. This is the sequence you have to write. S30. What is S30? Write down on chat box. After that, write case 1. Case 1 S1. That means what is the subboolean of case 1? Case 2. What are the subbooleans? S2, S3, S4. What are the subbooleans? What are the subboolean of case 3? So total 5 sub there you have 8 on chat box quick. Alright, write down in a sequence. So I've given you what actually you have to write. Just write down in a sequence. First of all, you can use your Samsung Notes or the Notepad. Write down there and copy paste over in the chat box. Quick, within 5 minutes, complete it. So only got response from Matthews. Any other responses? Guys, come on, do quick. Why are you wasting time? So S30, yes, Matthews is correct. Uh, zero element is I element is 30. So the booleans are 1, 2, 15, 30, 1, 3, 10, 30, 1, 5, 6, 30. And in case number 3 is 30. Correct, Matthews, everything correct. Okay, so go for the next one. If you have done with this first example, go for the next one. Try the second one. Second one is having a power set. Okay, it is not a SN. Okay, because we are used to with SN. Now this is a power set intersection union. The similar type here, the GLB is intersection and LUB is union. So just do it again. You have 8 elements over here. So you have 3 case. Each case is having I mean total number of subbooleans are 5 again. Okay, so just write down again same similar manner what will be the subbooleans. I want the answer from all of you. Please write down quick. Alright, so if you look at this case in this power set algebra, so it's something like phi is going to be your 0 elements and a is going to be the I elements. So first case, case number 1 is sub booleans is going to be, let me say S1, something like phi and a. Second case, case 2, is sub booleans phi with the first atom. The first atom is singleton A, and the complement of singleton is BC with A. S3 is phi, singleton B, AC and A, and S3 is phi, singleton C, AB and A. And the last case, case number 3, is having 8 elements, S5 is having equals to A. Sorry, power set of A. That is how we can construct. So I got again response from method, no other responses. Okay. Try to complete this stuff as home. Okay, as well. It's going to be your homework. These 2 questions also. Write down these 2 questions. Okay, these 2 are also homework. Complete this stuff. Okay, I will let you go now. Also, if you have any query regarding mid-semester exam